So in last class, we have started to solve a few problems on source transformation. Now we do solve one more problem. Take it down. Consider the circuit shown in the figure. Find the value of the voltage across 4 ohm resistance. Find out where is 4 ohm resistance. It is here, across which voltage should be calculated. Equals to what? The first step is using source transformation. So find out current source in parallel with the resistance, or else voltage source in series with the resistance. So I do take a current source in parallel with the resistance. That can be converted into a voltage source in series with the resistance. So these two part, current source in parallel with the resistance can be converted into voltage source in series with the resistance. 16 ohm is as it is. Then calculate a voltage using Ohm's law. V equals to I into R. 6 into 16. That is a voltage here. That is equals to 96 volt. All right. So remaining these two, everything will be as it is. 4 ohm resistance, 20 ohm resistance. It is 6 volt. Right. Next, what could be the next conversion? What could be the next conversion? Where, see, two voltage sources, they are connected in series. 96 volt and 6 volt, they are connected in series. These two can be converted into a single voltage source. These two can be converted into single voltage source. Write 3 resistors as it is. Write 3 resistors as it is. They are all are in series. It is 16 ohm, 4 ohm, and 20 ohm. Now, what is the value of this voltage source and its polarity? Can you tell me the answer? What could be the value of this voltage source and the polarities? Here, these two voltage sources can be converted into a single voltage source because they are connected in series. Because they are connected in series. Then 96 and 6, whether they are added or subtracted. The answer is 96 and 6, they should be subtracted because positive and positive, negative and negative, they are connected. Same polarities are connected here. All right. So answer is 90 volt. Then polarity, which is highest value here, 96 is the highest. So that positive should be connected to one terminal of the 16 ohm resistor and remaining should be a negative. All right. Next, the asked question is find out voltage drop across 4 ohm resistance. We know that voltage drop across 4 ohm resistance, voltage drop across a 4 ohm resistance can be calculated using Ohm's law. It can be calculated using Ohm's law. Voltage across 4 ohm resistance equals to I into R. So I is unknown here, but R is known, that is 4. How to calculate I here? Again using Ohm's law, I is equals to V divided by R. V is 90 divided by R. V is 90 divided by R is the total resistance of this loop because current flows in this direction. So, value of resistance here, it is not a only single resistance, instead it is R equivalent. R equivalent of this complete network is 16 plus 4 plus 20. 90 divided by 40. 9 by 4 amperes is the total current flowing in the network. So 9 by 4 current leaves the positive terminal. It flows through 16 ohm resistance, through 4 ohm resistance, through 20 ohm resistance. In these three resistors, 9 by 4 current is flowing because all are connected in series, so that to the negative terminal, a negative terminal, 9 by 4 current will come back. So that find out voltage drop across a 4 ohm resistance. What is total current here? 9 by 4 across 4 ohm resistance. Then the voltage drop across 4 ohm resistance equals to 9 volt. Can you will you solve the next question? Using source transformation, find the current through 5 ohm resistance. It is asked VTU examination December 19 6 months. Actually, it was given as assignment. How many of you solved this? Anybody solved this? Anybody tried this problem? Anybody tried to solve this problem? All right. So do not waste much time here. I do solve them. I do solve now. Uh, Identify where is 5 ohm resistance. It is here. It should be kept as it is. And everything should be converted into a simplest form using source transformation. First, I do concentrate. A 3 volt voltage source is connected in series with a 30 ohm resistance. Should be converted into so I do keep 5 volt as it is, or 5 ohm resistance as it is, 20 ohm resistance as it is, and I do convert these two into other form. A current source in parallel with a resistance, that is a 30 ohm. Then what could be the value of I? I is equals to V by R. V is 3, R is 30, that is equals to 1 by 10 amperes. All right. Next, next I do concentrate. 20 ohm resistance and 30 ohm resistors, they are in parallel. I do keep 5 volt as it is, 5 ohm as it is, and let us convert two resistors which are connected in parallel into equivalent resistance. So what is this value? Here 20 ohm is in parallel with a 30 ohm. That is R equivalent is equals to 20 into 30 divided by 20 plus 30. That is equals to divided by 50. So 60 divided by 5. That is equals to 12 ohm. So this value is a 12 ohm. All right. Next is again convert current source in parallel with resistance into current source in parallel with resistance into voltage source in series with the resistance. It is 12 ohm. We can see the polarities. So if it is a direction where it should be a positive and negative, same thing should be written here. Then what could be the value of this voltage source using Ohm's law? I into R. I is 1 by 10. R is a 12. That is equals to 6 by 5 volt. All right. Next is a current through a 5 ohm resistance is to be calculated here. Next, we do find here the two voltage sources which are connected in series, whether they are added or subtracted. Then tell me your answer. So hopefully these two can be converted into a single voltage source. Then what could be the value of the voltage source and its polarity? 5 ohm and 12 ohm is kept as it is. Yes, they are subtracted. The reason is, you can see here, the positive terminal, here it is positive, it is directly connected to one more positive of the source. Negative and negative are connected, so that they should be subtracted. So as a result, 5 minus 6 by 5. LCM is 5, 25 minus 6. That is equals to 19 by 5 or else 3.8 volt. Hopefully all of you got the same answer. Polarity, it should be equal to the larger value. Larger value is 5 volt. So that I do write the polarity according to the larger value. All right. So the asked question is calculate a current through 5 ohm resistance. And I do write here current through 5 ohm resistance, current through 12 ohm resistor, they are one and the same because they are connected in series. Do you agree? Yeah. So it is having a one loop, that is current I. The current I is same through a 5 ohm resistance as well as a 12 ohm resistors because they are connected in series. As a result, the using Ohm's law, current is equals to V by R. V is 19 by 5 here divided by, or else we can do, uh, V by R. V is what here? 3.8 divided by total resistance 5 plus 12. That is equals to 3.8 divided by 17. Then can you tell me the value of I here? 0.22. All right. So I can write here 0.22 amperes. Is it same? Is it the same current flowing through 5 ohm resistance? Yes. Have you understood? Have you understood the problem?